it's a very dynamic environment, and now I can actually seeing it in my daily work. Things changing, like when you plan an experiment on a specific day that you require specific condition, like it be weather or anything else, then suddenly something changed. You cannot perform any more experiment. Then you have to replan everything. Same thing happens on the space station. Something happens, then you have to completely change your plan. Plus, I really learned on how to interact with a lot of people, because interacting with people with different background, different culture, different style of work, you have to understand how to interact with them. So you need to approach them maybe different way. It's really interesting just to understand other people and see how we create a connection or develop our, let's say, a working relationship.
Time for another episode of the Cold Star Project, the podcast show about scaling space companies and all those unexpected crazy challenges. And this is a great chance to meet people from all over the place. I like meeting people from all over the world with different perspectives. And I'm here with analog astronaut Simone Paternostro. Thanks for being here.
Thanks to you for the invitation.
You bet. So we have a very interesting way of connecting here. I initially approached Dr. Gernot Groemer of the Austrian Space Forum. Yes, there is such a thing. And we're going to find out a little bit about that. And he said, oh, you need to talk to Simone. And we got connected up, and here we are. So this fella here has a PhD in engineering, surveying, and space geodesy, which is very interesting. And the topic, the space geodesy, I just started learning about, maybe a couple months ago, right? It hasn't been that long. He works for the European Space Agency and manages ISS payloads, which I hope to dig into a little bit. Obviously, we don't want to talk about any sensitive topics, but anything security related, we don't cover on this show. But but just in general, I've never met anyone who managed ISS payloads before, so I'm sure there's something we can talk about. So let's get started with the this question. How did you get involved with the Austrian Space Forum and Dr. Groemer?
Well, it was actually really by chance, because I was in the UK. It was September, October 2014. I was with my colleagues the PhD project in Nottingham, and we were just talking about space-related topics. And one of these was the astronaut selection process. So we were wondering what was the last one provided by ESA and when would be the next one. So just out of curiosity, because maybe some of us like to try. And while we were looking online, I came up with this analog astronaut selection. Actually, the Austrian Space Forum that year was opened a call for selecting new analog astronauts. So I say, yeah, why not? Let's give it a try. It might be fun. So I applied, and I went through the selection process. It was divided mainly in 3 cases. Unfortunately, at that time, I was not selected as an analog astronaut. The competition was very high because we had a lot of professional, even students with amazing background, experiences, and skills. So it was a very tough competition, and already being in the able to reach the final step where we were the only 15, it was really a big achievement for myself. But despite that, I liked what they were doing, because I got the chance to meet the organization, to understand what they were doing. It's all based on volunteers, that people passionate or they're really interested in the area or they want to know more about it. And so I decided to join the organization and support their activities and their mission. And in fact, a few months later, August of 2015, I joined the analog missions of the Austrian Space Forum. That year was on the Counter-Star Glacier in Austria. And I was in Innsbruck in their mission support center. I was part of what is called the flight control team in the mission support center, that is more or less managing and directing the mission with different positions inside. And that was mainly the start. With years, then I get a little bit more involved with the organization. I help them to organize some training courses that they provide for the volunteers that they come for the mission. Joined again a mission in 2018 that they performed in Oman. I was again in the mission support center in Innsbruck. And the end of 2018, again, they decided to open again another call for analog astronauts, because they wanted to increase their corp, let's say. And so I say, okay, let's give it a try again. I mean, it was fun the first time, and say, well, let's try again. It's still fun, and I can meet new people, and it's also a chance to increase my network of people. So I participated again. This time, luckily, I went through, and I was selected as a candidate our astronaut. Because once we were selected, then we had to go through a series of training in order to be qualified for the missions. And this one, I can talk to you a little bit more later. I'm not sure if you have any question about this.
Sure. Yes. So let's take a step back and explain what the purpose of the Austrian Space Forum is. Let's begin with that.
Well, it's an organization that is performing research in the space exploration field, particularly human space exploration. It was founded by a group of passionate people that wanted to still contribute to the field, even if not directly working in a space agency or a company. They felt the need to contribute to it, even because in Austria they didn't have the human space flight side of the space field, so they decided to create their own environment. So they started to perform this annual mission to support the understanding of what is to perform a mission of another celestial bodies. So involving scientists and researchers from institute that they wanted to test experiment or technology, hardware, everything. So they started with small mission using other facilities like the one in the desert of Utah, the DMARC, and then they started to develop their own concept, their own mission, also their own technologies. Actually, they developed in time also what are the two spacesuit simulators, the UDA X and S. So we have two models. And the main purpose of this suit is to more or less simulate the restriction and constraints that a spacesuit give to astronauts. Because performing experiment without any equipment on you, it's easier. But when you carry a 45, 50 kilogram suit on top of you, plus some restriction on your joint, that's really challenging. So considering also usually when you do experiment, you have to handle hardware, push buttons and everything. So also the feeling, the tactile feeling of your hands is completely different what you wear 3-4 different layers. So this is one of the main areas that the Space Forum is working, is trying to understand what are the difficulties, the challenges of performing missions on other celestial bodies, and also to create I understand the process behind, not only for the people on site, so on the celestial body, but also on Earth, on the ground. What kind of process we need, what kind of people, what kind of training and background. But they also do a lot of outreach activities, so they are really involved, especially in Austria, with local schools. They perform the promotion of studies of science, or in general STEM. Topics, so they are very active also in that field. They really want people to understand what we are doing.
Okay, that is really great. I'm curious where their funding comes from, but you don't have to answer that. Whether it's grants or privates or whatever. So I heard you mention the word process a couple times. I really like that. It's a big part of what we do here at Cold Star. Is process improvement. So an analog astronaut then is somebody who is not going to go up in a rocket, but is going to be sent somewhere on Earth to probably a fairly difficult environment, and then be put into this suit simulator to try out what is it like, because very few of us have had that experience, right? Of what is it like to be dressed up in this thing and then try and do normal stuff. Right, or mission activities as well, which may not be that normal. But everything is, giving a group of people this experience, I think, is quite valuable. And then, so the idea is that the space agencies will have this pool of people to draw upon who have some experience. Is that the idea?
You say space agency, or
Yes.
lost the last part of the question.
Okay. So is the idea of developing a core of astronauts, analog astronauts, to give the space agencies a group of people, a pool of people who have at least some experience with this stuff to be able to draw from?
Well, from the Austrian space point of view, it's not that one the objective. In general, is to have people that support the development and testing of performing research. Then if the analog astronauts by themselves, they decide one day to apply for the call for astronauts at the European Space Agency, then it depends on the people at the space agency deciding if the experience that we had might be significant for real astronauts or not. But I mean, that's a top of two different things. I mean, being an astronaut, obviously, it's much more challenging from many different aspects. So that's why we are not trying to emulate that thing. We're just trying to give our own contribution. Okay. Then the Austrian Space Forum created this pool of analog astronauts in order to have enough people to get involved, because being volunteers, it's difficult. Everyone has their own life, job, families, and everything. Going on mission usually requires at least 2-4 weeks. You have to be fully available for that time. So having many people, you have a much bigger pool of candidates that can go on mission.
Okay, so that clarifies that. So for you then personally, what was your big takeaway from this experience, and how does it affect your career going forward?
Well, I have to say that I didn't realize that they had a kind of effect on my career, because when I moved from my PhD in Nottingham and I completed it and I moved to this position at the European Space Agency, actually I believe that my experience with the Austrian Space Forum might have played a good role in it, because the position itself is dealing with the human spaceflight, so astronauts and experiments on board of the space station. And it's a big environment with a lot of players and roles, so you have to interact with a lot of people. And I had already this kind of experience in the Austrian Space Forum, where the team is quite big compared to standard, and you have to interact with a lot of people, manage, organize. So the whole experience itself, I think it played a good role in the selection for the position. And I'm really happy that actually helped in that way. Maybe in the future we'll have for other position whenever there would be the need to change position. So who never knows? It's still experience, plus I'm enjoying it, having fun. So that's the main important thing for me.
Right. Is there a big takeaway from that experience of running that analog mission that you bring to your work today? Something maybe about planning or the unexpected?
Oh yeah. Obviously, because there are a lot of things. It's a very dynamic environment, and now I can actually seeing it in my daily work. Things changing, like when you plan an experiment on a specific date and you require specific condition, like it be weather or anything else, then suddenly something changed. You cannot perform any more experiment. Then you have to replan everything. Same thing happens on the space station. Something happens, then you have to completely change your plan. Plus, I really learned on how to interact with a lot of people, because interacting with people with different background, different culture, different style of work, you have to understand how to interact with them. So you need to approach them maybe a different way. It's really interesting just to understand other people and see how we create a connection or develop our, let's say, a working relationship.
Right. Okay. Now, let's jump back a bit. I am curious about how they go about selecting you to be an analog astronaut. You submit a resume package, I imagine, and then there's some kind of interview. Is there a practical portion to it?
Correct. As I mentioned before, there is a 3-step process. The first one is the application. It looks like a standard job application where you have the CV and a motivation letter sent to the organization. That they evaluate your profile and your motivation, and then if they like you, they invite you to participate to the second step. The second and third step are in site, in Innsbruck. It involves a lot of tests, and that can be like general knowledge test, hand-eye coordination, physical and psychological tests, team working. You cannot even remember how many tests we went through. And after the second step, actually you go through a full medical check because they want to be sure that you are healthy enough to carry 45, 50 kilograms of spacesuit for 4 or 5 hours. So you need to be fit for that. And so the selection itself is nice. It involves a lot of interaction and some particular tests sometimes that maybe you might not understand. But probably they realized from there your skills and your capabilities. And that was the fun part, trying to understand each test, how it was for, what was for, and try to understand if I did it right or not, or if I need to improve, try to understand my weaknesses and my best skills.
Well, that's a very healthy definition of fun. I don't know if everyone on the planet would share that, but it seems to have worked out well for you. So tell us a bit about your role. The title is Multi-increment Payload Planner for the ISS. So what the heck does that mean?
Well, I'm not sure if you're aware, the timeline in the space station is divided in different, let's say, periods. Each period more or less is 6 months, around 6 months, but it depends. Sometimes it might change depending on the flights. And then during these 6 months, they are called increment pair. So this is why it's called multi-increment, because you take a couple of increments. Each agency involved in the space station has to plan in advance the experiment or maintenance that they want to perform on board of the station. So as a planner, we plan in advance what kind of activities we need to perform on board with the information that we have from other team members. There's another important role in involved that is called the payload integration manager. It's the one following the development of the payload from cradle to grave. So from the beginning when it decided, the space agency decided to perform it until the end. So it follows along the timeline, the payload. But then you need to know from them when the payload is ready to be launched and performed. And you have to check with all the other payloads that are ready more or less in the same time frame, that you have all the resources on board that you need to perform them, and they do not have any conflict between each other, that you satisfy all the constraints and requirements coming from the scientists. Since each agency for that time frame has a specific amount of resources, so you need to optimize the outcome or the scientific outcome, or in any case, what you need to perform the investigation on board in that time frame. So it's a kind of optimization and process as well.
Okay, so there's a little project management. There's some materials selection. How about checking in on like what's going to happen to these supplies as they're in the rocket going up, and the potential of vibration damage or something? Is that in your area?
No, this one is part of the payload developer. So the payload integration manager just follow the development of the payload, but the payload developer, so the company that builds the hardware, is aware of the environment of the launcher. So depending on the information that the launcher provider gives to the developer, then they know how to develop the hardware. So this is a totally different part of the overall picture for the experiment. In our case, we take the information related like the requirements, so what the experiment needs, if it needs to be performed within a specific time frame, because there are some experiments that requires to be performed either as soon as possible or within a specific window of time. The amount of time that required, because that's one of the main resources on the space station, is called crew time. It's actually how much the crew member has to work on it. And so you need to optimize, especially that one, in terms of number of investigation that you would like to perform. It's a continuous back and forth, especially when flight changes, or the cargo or the crew vehicles change for whatever reason. This impacts our plan, and then we have to replan again and see what are the impacts of moving vehicles. And it's also in this case, also sometimes the fun part. Sometimes it's quite challenging because sometimes changes are quite sudden. So you have to do everything quickly to reevaluate the situation. but it's also nice because you interact with a lot of other people around the world. So I'm in contact almost on a weekly basis with people all around Europe, but also around the world, with NASA, JAXA, CSA. That's really amazing how we can work and collaborate together from all over the world for a specific objective.
This is Jason Kanigan from Cold Star Tech, and I'm excited to share with you a new offer from Cold Star that we are bringing out to help both space founders and venture capitalists who fund space companies. And it's on two levels. The lower level is a VC who is looking at possibly funding a space company, but they just don't get it. Right? And a lot of tech founders want to come out and create some sort of technical capability, but they do not understand business. And so you'll look and you'll go, where's the customer here? Where's the business model? And they'll go, huh? But I want to make rockets or something, right? And it's really cool. Well, that, as we know from the dot-com era, is not a viable business model. And so you bring us in. We've got great technical expertise on the space side, folks who have done this sort of assessment before, like our technical engineering advisor, Dr. Rick Fleeter, myself in the process engineering field, plenty of other people with brains to look at this problem so that you don't have to blow your brains out trying to figure out how to make this work. And on the company side, it's a benefit for them because we will show them the roadmap to how you're going to get funded, how you will want to fund them, what changes to make to get VCs excited about putting money in. And so that's good for you. Right? The second level is at a deeper and higher level at the same time. It is for venture capitalists who have given a seed round to a company, a space company, and that has gone on for a little while, 6 months, a year, something like that. And it is time, as COVID has made it, to double down or get out. Those are pretty much the choices, right? It's time to invest further in a thing we already know, which seems to be the direction VCs are going in right now. They don't seem to want to look at new things or stop, just kill the project. And so the good news is, in that situation, there's a lot more going on. There's more meat for Cold Star experts to get in and analyze, right? You're going to have processes in place, whether they know it or not. We'll be able to flowchart those and maybe accurately document them for the first time so we can get some kind of value chain going in the organization. We'll be able to test whether the leadership is the right group of people or whether you're missing something, the strategic direction, the business model, all this stuff. So if this sounds interesting to you, reach out to us. You can email me at jason@coldstartech.com or just connect with me and message me on LinkedIn. That's probably the best way to do it. And I am excited to talk to you. The kind of transformation that we're able to offer here is beyond anything you'll see out there. And as a VC, this will save you so much time and energy, right? Like if you're a VC and you've got 100 companies to look at, you've got 3 days a year to look at each one maybe, right? That's not really good enough, is it? Wouldn't it be better to have experienced, expert space people who understand space, right? Look at this investment and tell you, here's a grade. Right? Here are several grade areas. Is this thing ready to pour gasoline on the fire, or is it just going to go up in smoke? This is Jason Kanigan from Cold Star Tech. Let's get back to the interview. Would you say you're spending more of your time with like a Gantt chart or more of a bill of materials, or is it kind of both?
I would say more. That's a good question. Most of the time, it's either the phone or writing email or Excel file presentation for meetings, which you have to present your ideas or plan or any issues that you might find. So it's a mix of between different things, so different tasks.
Okay. I'm curious about the crew time. I do a lot of estimating for clients, and I find that they continuously underestimate the amount of time activities will take by 2, 3, 4 times, sometimes more. They think something will take 1 or 2 hours, and it'll take all day. How is that in the ESA for the ISS? Do you find that it's pretty one-to-one on the planned versus actual, or is there a bit of variance?
No, there is a bit of variance. There are some experiments that they are overestimated. So in some cases, we managed to spend less time than expected. And this is more or less, I would say, the average likely, because they try to be on the safe side.
Right.
But in some cases, something might happen, something is not fitting, or there is an anomaly that you didn't expect it, and sometimes you really can overrun of several hours. So then you can go really factor 2 or 3. It's quite rare so high, but it can happen.
Okay, that makes me wonder. Everybody can imagine. Okay, what happens if it takes too long and there's too many things that need to be done in too short of a time? But what about the opposite? What happens if you've got downtime or dead time, like the thing is done in 6 hours and we thought it would take 8? What do you do with those 2 hours?
Well, luckily there is it works in this way on the space station. Usually you have prime activities, so activities that are scheduled on a specific day and time because they need to be done. And then there is what is called reserve activities. So activities that are not planned, they are not in the schedule of the astronauts, but if there is some free time, they either can decide themselves which one to perform, or maybe they receive a call from down saying, hey, since you finished in advance, can you do one of these activities? So they always have backup plan in case everything goes very, very smooth and everything is done very quickly. So luckily, this is also one of the things that we are working in all the space agency. We always have a set of prime activities and a set of reserve activities that can be planned anytime whenever there is a chance.
Okay, so there, we just learned about some of the priority system of task assignment. Okay, let's go into your education here for a bit. So I started learning about space traffic management and space situational awareness, and as soon as you start doing this, you run into this thing called the Kalman Filter. And every PhD seems to have in this area seems to have a paper published with that Kalman Filter in its title, right? And they're working, tweaking, developing their own version of it, and that. And you've done some work in it. So I'm curious about what you have discovered about using the Kalman Filter in calculating flight plans and attitude and things like that. But I guess let's begin with explaining what it is. What is the Kalman Filter in a simple way?
Well, this was part of my internship in Airbus during outside the PhD, was before the PhD time. Well, the Kalman Filter is a model that evaluates specific, let's say, property. And in my case, it was the attitude of the spacecraft. So how it was facing Earth or the stars or Sun, and this model tried to figure out the exact position or attitude in this case of the satellites based on some measurements. So the model, the code, let's say, takes as input the measurements done by sensor. In the case of my internship, it was the measurement from the gyroscopes and from the star tracker. And based on this, try to evaluate the attitude of the satellites. So it takes the measurement that they refer to a specific, let's say, attitude of the spacecraft at a specific time, but the measurements are not perfect. They have an error because all the sensors are not perfectly calibrated in any case, but they're not perfect. In general, they have some background nodes that create an error in the ASCP. And so the model itself uses the measurements to validate for the initial estimate. Then it propagates based on the model that you have of the spacecraft. So you know that this spacecraft has to follow a specific law of physics, of the orbit, of the dynamics. And so you propagate, it's called propagate the position based on that measurement. And every time you have a new measurement coming in, you check that your estimate based on the mathematical model more or less reflect what's coming in your measurement. And then it continuously check and takes the difference between the measured and the calculated position or attitude of the spacecraft and adjust itself to try to understand how much are the error, if the model is correct. So this is more or less what a Kalman filter does. It's a loop that evaluates the measurement and the model that you have, and try to figure out if the model is correct, and so your estimates are good enough to evaluate the attitude of the spacecraft. In my case, with the internship, we wanted to check the effect of a possible error source. There was a misalignment between the star tracker and the gyroscopes that could change depending on the thermal load on the satellite. Since it was satellites usually go in the shadow or they face the sun depending on the orbit, and this create structural change and could be misaligned the two sensors. And this generates an error, and we would like to want to see if we modeled the error in a good way, and depending on which Kalman filter we use it, which one could give a better estimate. So the main outcome was that one of these filters could give a slightly better estimate of the altitude compared to the others. And then this was used by the company in a report for a proposal they were doing to how to enhance future spacecraft.
Okay, so trying to reduce uncertainty is a big part of using this thing, and getting to confirmation of, okay, does this model actually tell us what we want it to be doing?
What's going on? Yeah.
Okay, and I'm sure we're going to run into that thing a lot more in this program with other guests of that, because I seem to run into it once a week where I must read a paper that's related to it. So I'm going to read this item out here from your LinkedIn profile. You note simulation and testing in MATLAB/Simulink during your doctoral experience at the University of Nottingham. So you got to use these things, MATLAB and Simulink. I've never been there. I don't really even know what this is, but it sounds cool. So I'm curious what the facilities were like and how you worked with them.
Yeah, MATLAB Simulink is a pretty much standard, let's say, software used in universities to generate or write code in order to make computation, make also simulation. Depending on the set of tools that you install together with the basic software, because the company providing the software allows you to install add-ons or other features that you can implement. Then you are able to simulate more features or create a more sophisticated system. So this is very useful in the university field to start to practice with codes and creating simulators. So this was one of the main tools used during my PhD, not only by me, but also some of my colleagues. I was part of a big project called Innovate. It was European Union funded project. The University of Nottingham made this proposal to the European Union for a big project involving 13 national researchers from all over Europe and a couple of them in worldwide. And the project itself was focusing on analyzing and developing specific technologies or technique to optimize performances for aviation. So we analyzed different areas, like for my case, navigation, but we had also ground operation, fluid dynamics and structures, controls. So it was very wide. Each of us was focusing on one specific topic. And then the idea was to combine the different technologies and try to understand how they perform together and how much they could improve the performances of the aircraft. So in my case, I developed this code in MATLAB. It was used to evaluate the performances of the satellite navigation system of the aircraft. The navigation system itself, the quality and the accuracy of the position provided by the navigation system depends on the number of satellites in view with respect to the receiver. So how many satellites the receiver can see and their relative position. But during the flight, an aircraft can change its altitude, so it can bank and roll, depending on the maneuver is performing. And some of the satellites could be lost on this way, or even an obstacle around, like thinking an aircraft landing close to airports or skyscrapers can lose some of the satellites because the obstacle are between the satellites and the receiver line of sight. So I analyzed this aspect on how much the attitude of the aircraft is affecting the accuracy of the position, and checked also compare the different scenarios using a single constellation like GPS or using combined constellation like GPS and then Galileo, the European version, and also the Russian system. So the main thing was to understand if it's worth to implement a multi constellation in an aircraft in order to improve the performance and ensure that the accuracy of the position is good enough for using the system.
Okay, very cool. I've been kind of laughing at myself the whole time you've been answering because I've revealed my university noobiness about these programs. Right? None of the PhD instructors or professors I've interviewed have ever mentioned it because it's probably so ubiquitous, like it's just everywhere that they don't think about it. But now I know. I had this like supercomputer sort of thing in my head. See, I went to school in the middle 90s and I took business administration and operations management, and computers that were wired into the internet all the time were a new thing, having a lab like that. So this is the fun of discovery here. So let's wrap up with this question then. I'm curious about where you visualize going in the space field in your career. Obviously, you're happy where you are right now, and it sounds like got this crazy day job where you learn a lot, right? And it's project management. There's some human resources, materials management, a little engineering, and it's fun. Where do you see yourself going over the next, say, 20 years or so?
Well, that's a very good question because a lot of things might change. I mean, for me, I really hope I can stay in this position until the end of the access. That would be great, since being born in an era more or less where most of the things are already going, and I enter in the job field when everything was already set for the space station. I just arrived and everything was there, so I just needed to follow what already they're doing. So at the end of the SS, I hope that I can maybe move to something different or even earlier, depending on what would happen. Since now it looks like that all these space agencies are moving in the direction of human exploration. So being a little bit more involved in this field, so the first human colony on the moon or first trip to Mars, that would be amazing. It would be great. So many people are also interested in the field, but we just need to wait and see what happens in the next years if it will become a reality.
Right, a few more capabilities need to be created before the human exploration part of it can go.
It's moving. I mean,
Luna, Mars, wherever. Yeah, it is happening. Yeah, we're having guests on this show on these topics. So.
Oh yeah, I think you've probably heard about the Getaway. So this is the next small space station around the moon, and actually ESA and NASA are already working on it together with the other partners, Russians and Canadian Space Agency. So it's happening, just a matter of when.
Right. All right. Well, awesome. My guest has been Simone Paternostro. He is a PhD in engineering, surveying, and space geodesy, analog astronaut, member of the Austrian Space Forum. And I guess you started in Italy and you ended up in Holland right now. Is that true?
Correct. I studied in Italy, then moved to Germany, UK, and now Netherlands.
All right. And if somebody wants to get a hold of you, what's the best way to do that? LinkedIn, I guess?
Yeah, LinkedIn for sure. I constantly check it. So yeah, of course, that one is the best.
Okay, cool. Well, thanks for being my guest.
No, thanks to you, Jason, for your time. It was really a pleasure to be here with you.
This is Jason Kanigan from Cold Star Tech. Thanks a lot for listening to this episode. I hope you enjoyed it. If you do want to get email notifications of upcoming episodes or episodes that have just been released, and maybe a little news sprinkled in here and there, you can sign up for email notifications at coldstartech.com/MSB. That's short for Make Space Boring. That's another little show that I do. It's once, twice, 3 times a week, something like that. Anytime there's news or an update on who I'm meeting and what I'm studying in the space field. So you can go check that out. On the YouTube channel, I can do something that I cannot do on Anchor for the audio only side of things. The YouTube channel allows me to have playlists, and so you might want to go to the channel, the Cold Star Tech channel, and check out those playlists, because you will find you can go down a rabbit hole basically into several areas like space law and policy, small sats, and I think that's a lot easier than trying to scroll through 130 episodes or something like that looking for the thing that you want. So I recommend going and checking that out. And remember, if you're ready to take your space business to the next level, or you're a VC looking for deep and very valuable insight into a space company you're looking at investing in or investing further in, come and talk to us. Thanks for listening.